mai 1940. « 14 juin 1940. « 19 juin. Tué à 40 ans, 2 jours avant l'armistice, Maurice Jaubert fut jusqu'à l'absurde engagé dans son époque. Chef d'orchestre. Musicien de film. Partisan du Front populaire. Critique à la revue Esprit. Catholique antifasciste. Méditerranéen passionné de montagne. Musicien presque autodidacte, il est à 19 ans le plus jeune avocat de France. Il naît 3 jours après le siècle à Nice. Une ville où devaient se rencontrer la musique et le cinéma. Nommé en 1930 directeur musical de Pathé Cinéma, Maurice Jaubert considère le film sonore comme une ouverture nouvelle pour le compositeur.
Nous réclamons une musique populaire. Et contrairement aux apparences, nous ne pensons pas ouvrir ainsi une voie facile.
Tu veux danser avec moi?
Nous ne venons pas au cinéma pour entendre de la musique. Nous demandons à celle-ci d'approfondir et de prolonger en nous une impression visuelle. Nous ne lui demandons pas de nous expliquer les images, mais de leur ajouter une résonance de nature spécifiquement dissemblable. C'est le rôle du musicien de film de sentir le moment précis où l'image abandonne sa réalité profonde et sollicite le prolongement poétique de la musique. Le musicien au cinéma doit saisir le rôle de la musique par rapport aux images, ainsi que le rôle du son non musical et son emploi par rapport à la musique, successif ou simultané. C'est alors que le compositeur devra demander si les images n'imposent pas à la musique un style spécifiquement cinématographique. 3 notes d'accordéon, si elles correspondent à ce que demande une image particulière, seront toujours plus émouvantes en l'occurrence que la musique du Vendredi Saint de Parsifal.
Là encore que je bricole dessus. On avait des choses plus sportives que de faire marcher un disque avec un doigt.
La musique doit se souvenir qu'au cinéma, son caractère de phénomène sonore l'emporte sur ses caractères intellectuels, voire métaphysiques. Plus elle s'effacera derrière l'image, plus elle a de chances de découvrir pour son compte personnel de nouvelles perspectives.
Et cependant, hier encore, souviens-toi.
L'œuvre d'art devra céder le pas à la vie. Le cinéma aura été pour quelque chose dans cette évolution, en donnant une si grande place à la musique utilitaire par opposition à la musique désintéressée.
Musicien de circonstance, Jaubert participe au spectacle de l'Exposition internationale des arts et techniques 1937.
La musique ne doit plus être objet de musée, mais prendre son point d'appui, toute sa force et son sens dans la vie d'un peuple. «
38 partitions de films, 8 musiques de scène, 4 ballets et 40 œuvres de concert, la face cachée de sa production. Faute de mieux connaître ses œuvres, le public a retenu de Jaubert, sans toujours connaître son nom, les thèmes de ses films devenus les classiques du cinéma français d'avant-guerre. 14 juillet, Zéro de conduite, La Talente, Drôle de drame, Carnet de bal, Le Quai des Brumes, Hôtel du Nord, Le jour se lève. Dans le film Nuit de décembre, Jaubert dirigeait l'orchestre. Son adieu au cinéma, c'était en juillet 1939. André Bazin écrira, parce qu'il n'a cessé de trouver dans le plus haut respect de l'œuvre cinématographique, dans un même amour de la musique et des hommes, la source de son inspiration et les règles de sa technique, Jaubert est de ceux qui ont le plus travaillé à la grandeur et à la dignité du cinéma français.
Hello everybody, I'm Skip Alzheimer. Welcome to the AV Geeks Lunchtime Streaming Show, where we've been digitizing a lot of foreign language films. And there's this whole series of this Chroniques de France, which are kind of these like news segment things. And I think they're pretty cool. I've shown this a long time ago. This was part of a show that I did called Ridin, Revolution, and was about films about kids doing revolutionary things in the early 70s. Enjoy.
Come on, Mike. Get out. Mike, you'd better go home now.
Mike! Hey! Get down! Get down, Mike. It's coming down.
This is where you discuss. what is going on? I guess I need a better tripod. This is just horrible. It's really bad. It's mounted. Alright. For those of you that have AV Geeks bingo cards, Skip complaining about his webcam. You can mark that on your card. Okay, this is another one that we haven't shown in a while. Although we've shown one of the songs on a early toe tapping tournament bracket. And I think it's time to watch some Canadian puppets. Enjoy.
Pizzas aren't allowed in school.
What? You mean my teacher doesn't like tempting pepperoni?
Mm-mm.
With beautiful mushrooms?
Nope.
Little green peppers?
Not even those.
Oh, you can't mean that.
You can't eat during class, Jimmy Joe. You're going to school to learn, not to eat.
Well, how about a pot roast?
Mm-mm.
Hot dog with mustard?
Negative.
Jelly beans?
Not in this continent.
Would you settle for blackjack bubblegum?
No. What was that?
Oh, that's my alarm clock. I gotta be going because I gotta catch the bus. I don't want to be late.
Jimmy Joe, where are you going with the pizza? You forgot your school books. He forgot his school books.
Oh boy, oh boy, oh boy, oh boy. Here they come. First day of school, yelling and screaming. My stomach. Oh, I need some Pepto-Bismol. Relax, dearie. Relax. Oh, this year things are going to be different. All the boys and girls are going to do things right this year, as sure as Miss Fay's my name and bus driving's my game. Oh, I can see it all now. I feel a vision coming on. Okay, Charlie, cue the dream and find me an announcer real quick.
Hi, Miss Fay. I'm Bruce.
Hey, kid. You pant real well. Now let's hear your voice.
Sure thing, Miss Fay. Testing. 1, 2, 3. Testing. Mary had a little lamb. Its fleece was white.
All right. Don't overdo it, kid. You'll do just fine. Roll it, Charlie. Hit it, Brucey, baby.
Here we are, ladies and gentlemen, in Miss Fay's dream. A dream where all the children follow the school bus safety rules. Always leave home with enough time to get to the bus stop before the bus arrives. And always go straight to the bus stop. It's not a good idea to cut through empty lots or back alleys.
That's right, Brucey baby. Back alleys and empty lots can be very dangerous. Don't forget the strangers, Brucey.
Yes, and you should never accept a ride from a stranger, not even if you miss the bus. Another thing you should remember is to walk single file on the left side of the road if there isn't any sidewalk. That way you can watch the oncoming cars.
Oh, yeah, and walk off the side of the road where you can't get hit by a car.
Thank you, Miss Fay.
Any time, Brucey baby, any time.
Once you get to the bus stop, you should always line up away from the road. But be careful not to step on anyone's garden. You've got to be pretty orderly at the bus stop, because if there's any pushing or shoving when the bus pulls up, someone could get hurt, or even fall under the wheels of the bus.
Oh, Brucey, that's just too terrible to think of.
I know, Miss Fay. That's why you should always line up nice and calm, and let the little kids get on first, so no one gets hurt.
Okay, cut the dream, Charlie. Brucey baby, I gotta think about that for a while. And thinking always makes me hungry. Hey, kid, You want to peel me a grape?
Sure thing. And how about an avocado?
Hi, Heather. My name's JJ. How old are you?
7.
You go to school?
Yeah.
Yeah. Do you take the school bus?
Yes.
Yeah. What's the first thing you gotta remember when you're getting to the bus stop?
Go straight there, not through any alleys or empty lots.
No, you don't want to go through any alleys or empty lots because you might step on some bottles and cut your foot, right?
Right.
Yeah. And what else?
Don't take rides from strangers.
Well, that's the most important rule of all. Hey, that's terrific. Yeah, and do you know that if there isn't a sidewalk to walk on when you're going to the bus stop, what must you remember?
Walk on the left side,
Why's that?
'cause you can see if the cars are coming to you.
That's right. And what should you do when you get to the bus stop? Always line up away from the road. That's right. And be careful not to step on anyone's what?
Feet.
No, on the flowers. Or the lawn, right? Because
Right.
people plant all the nice flowers, and you don't want to damage them, right?
Right.
And then, and one more thing. What else? At the bus stop, no pushing.
No pushing.
Yeah, because someone might get hurt. You did just terrific. Give me a kiss, will you? Oh, yeah, let me give you one.
There's nothing like fresh peeled grapes to help the thinking process.
Mm-hmm. And avocados, too. How about your dream, Miss Fay, the kids, and the school bus safety rules?
Oh, yeah, gotta get back to my dream. Roll the dream, Charlie. Take it away, Brucey baby.
Thank you, Miss Fay. You should always remember not to run or shove when you're getting on the school bus. Use the handrail if you can, and step up quickly and go straight to your seat.
Pushing and shoving means someone could fall down and get hurt.
Yes, and when you're seated, you've got to remember to keep your arms and legs to yourself. Never out in the aisles or out open windows. You should never throw books or food around the bus either. What if you hit the driver with something?
Instant accident, that's what.
And food. You shouldn't eat on the school bus because...
Oh, heavens, no. Salami and chopped egg sandwiches do not go with the smell of my eau de cologne. And besides, someone could sit on your banana.
Yuck. Oh, and one of the most important things is not to scream and yell, especially when the driver comes to intersections. Too much noise can make the driver nervous.
I always think a little quiet conversation is so much more cozy. I feel a song coming on. I gotta do a little shantoozin'. Kid, this is gonna curl your hair. Taking it cool is riding it safe. Taking it cool is riding it safe. Taking the school bus and riding it right gets you there safely, and that's out of sight. Learn all the rules to keep you cool. Ride by the rules, and you know that you'll be riding it cool, riding it safely, riding it cool, riding it safely. Ooh, you're doing just fine. Well, kid, ain't I great?
I'm speechless.
Heather, we're going to go over the bus riding rules. Do you know some of them?
Step up quickly and find your seat.
And use the handrail, right?
Right.
And then after you're seated, what happens?
Keep your arms and legs off the aisle.
That's right, because someone might trip and fall and get hurt, right?
Right.
And what do you do with your books and your lunch?
Don't throw your books because you might hit the driver.
Or one of the other children, right?
Right.
And your food that you have in the lunch bag or in the lunch pail?
Don't eat it on the bus, eat it at the school.
Right. And one of the most important things is not to what? Scream.
Because if you're at an intersection, you might get the driver
Scared.
Yeah,
and take his concentration from driving, and then he might get in an accident, right? So those are the bus riding rules, and you did very, very well, and I think that I deserve another kiss. Come on, give me a kiss.
We're coming up to the tricky part here, Brucey. Can you handle it?
You've got to be careful getting off the school bus. Always wait until it stops before you leave your seat. The bus could lurch and you'd fall.
And no pushing and shoving.
That's right. If you let the kids in front off first, it will go much faster and safer. When you step down, hold the handrail so you don't fall. If you have to cross the road, go up about 10 feet in front of the bus, then look both ways all the way across. Then go directly to the schoolyard or go straight home the same way you came.
Cut it, Charlie. You did just fine.
There's another set of rules that we're going to talk about, and that is getting off the school bus, okay? Do you know what they might be?
wait until the bus is stopped.
That's right. And then you can leave your seat, right?
Mm-hmm.
Okay. And what must you not do when you're getting off the school bus?
Push and shove.
Never, never, never. And you must always what? Remember to?
Let the kids up front go first.
That's right. Oh, that's good. You're remembering these rules. And then when you step down, what's the one thing that helps you?
The handrail.
That's the same handrail that was there when you got on, right?
Right.
Yeah, sure. And then, if you have to cross the road, where do you go first?
10 feet ahead of the bus.
Mm-hmm. And what's the reason for that?
So you can see around the bus and see what's coming.
And who helps you sometimes to tell you when to cross?
The bus driver.
Yeah, you watch them. We don't want anyone to get hurt. And then, what do?
Go straight to the school.
That's right. No playing on the way. Go right to school. That's why you came. And Heather, I want to thank you. You're just a terrific, terrific girl, and you're my friend, and I'm going to let you give me a kiss. Hey, can I give you some more kisses?
Yeah.
Okay.
Yeah, but I don't know what we're supposed to be doing.
Just do as I do.
Can I bring my piece of pie?
No! Get rid of it!
You gotta line up single file. You gotta stay back from the road.
Oh, yeah.
You never push and never crowd. Take care, man, care, and not too loud.
You gotta let the big bus stop. You gotta go right to your seat.
Mm-hmm.
You never run and never shout. Take care, man, care until you're out.
Stop, stop, stop. Then you can look all around. Think. When you act and you know you'll be safe now.
You gotta keep your head inside. You gotta keep your arms in two.
Oh, yeah.
You never fight and never throw. Take care, man, care, and take it slow.
You gotta let the big bus stop. You gotta let the front off first.
Sure thing.
You never rush and never run. Take care, man, care until it's done.
Stop. Then you can look all around. Think. When you act and you know you'll be safe now. Oh, yeah.
I love it. This is great.
Coochie.
You gotta always cross in front. You gotta look both left and right.
That's right.
You never run and never skip. Take care, man, care, so you won't trip.
You gotta know the safety rules.
Oh,
You gotta use them all the time.
oh, yeah.
You never shirk and never fail. Take care, man, care, and that's my tale.
Mhm.
So, members of, I think Nick of Found Footage Festival and I have talked at length about the inappropriateness of having Mae West in a children's film, especially one that was made in the 80s, where the kids have no idea who Mae West is. And then all those weird, like, they're weird. It's so weird. But the Beacon Beacon Productions also made another film that I've shown, which is Let's Find Something Better to Do, which has someone in a full-sized owl costume who's also wearing a police officer's uniform. So I'm going to try to track down some more Beacon Productions featuring puppets because, yeah, so good. And both those films have songs, so yeah, I'm going to try to find some more. All right. I don't think I've shown this one. I looked in my database and I don't think I have, but this is Geography of Hawaii and Alaska. If I have recently, let me know and we'll watch something else. I just couldn't find it in the database. Enjoy.
This is Juneau, capital of Alaska. This is Honolulu, capital of Hawaii. Alaska and Hawaii, our 49th and 50th states, extended the boundary of the United States to south of the Tropic of Cancer and north of the Arctic Circle. Alaska has a rich and colorful history. State William Seward negotiated the purchase of Alaska from Russia for $7,200,000. Alaska was facetiously nicknamed Seward's Folly and Seward's Icebox. But after big strikes of gold were made in northwestern Canada in 1896, and then in Alaska in 1898, attitudes quickly changed. Americans came in a great gold rush. Many mining camps became towns and cities that today include Nome, Fairbanks, and Juneau. The gold rush brought thousands of Americans to Alaska. In 1912, Alaska became a territory, with Juneau the capital. Almost a half-century later, in 1958, Alaska entered the Union as the 49th state. What is this new state like? Who are the people that live here? These are people who live in the largest state. Alaska is 1/5 as large as all the 48 states it joined. Within this great area is a variety of landforms, including 3 main mountain ranges: the Brooks Range, the Alaska Range, and the Pacific Coast Range. In the Alaska Range is majestic Mount McKinley, the highest mountain in all of North America. Glaciers, giant rivers of ice, wind down from many of Alaska's mountains. Along with the mountains, Alaska is also a land of valleys and tablelands. The Tanana Valley and the Matanuska Valley are 2 of Alaska's most fertile areas. Much of Alaska's farming is done here. Alaskans don't produce very much of the food they need, so they have to import most of it. The Alaskan growing season is short, but the summer days are long, with as much as 20 hours of daylight. So vegetables sometimes reach enormous size. These soils also produce lush grasslands. Dairy cattle thrive here. Many of the products of the Matanuska Valley are shipped to nearby Anchorage, the largest city of Alaska. Most Alaskans live in cities and towns. Like Anchorage, most of these cities are located along Alaska's coastline. North of the Brooks Range is Barrow on the banks of the Arctic Ocean, the northernmost community in the United States. Barrow is a trading center above the Arctic Circle. Most of the children at this school in Barrow are Eskimos. This northern region of Alaska is a vast and mostly unpopulated tundra land. In 100,000 square miles of tundra, only about 4,000 people live. Most of them are Eskimos. They live and work mainly in towns like Barrow. Nome is southwest of Barrow on the Bering Sea. Farther along the coast are the Aleutian Islands. The chain divides the Bering Sea from the Pacific Ocean. Most of Alaska's main cities lie on its southern or Pacific coast, including Juneau, the capital of Alaska. The climate in Juneau is mild. The winters are not severe, and the summers are cool and pleasant. Winds blowing across the warm waters of the Pacific Ocean help to temper the climate in this part of Alaska. But the waters off Alaska's southern coast are even more important for another reason: salmon. During the salmon runs in the spring and fall, the fishing fleets are busy hauling in the catch. Although the 1964 earthquake severely damaged the fishing industry, it recovered quickly and regained its importance in Alaska's economy. The damaged canneries also recovered soon afterward. The canning and fishing industry is Alaska's second main source of income. Alaska's main industry is based on its mineral wealth. Gold mining, once important in Alaska, is only of minor significance now and declining. The more common minerals, gravel, sand, and clay, have become more important than gold because of their use in construction. Today, oil is Alaska's main resource, along with natural gas. Major strikes of oil have drawn prospectors to Alaska as gold once did. Coal is also mined in Alaska in large strip mines. Most of the coal is used in military bases in the state. Lumbering is another growing industry. Alaska's vast timberlands are a potential source of wealth for the future. But many of Alaska's resources have not been fully developed because of the state's main problem: transportation. Rail transportation and roads are still very limited. To travel the great distances in their state, Alaskans depend on planes. Almost every town in Alaska has a landing strip. The major cities and towns are serviced by the commercial airlines. Land and sea routes connect Alaska with the other states. The Alaska Highway is the main land route into and out of Alaska. Travel by water is possible through the Inside Passage along Alaska's sheltered Pacific coast. A trip here offers one of the world's most scenic cruises. But because of the distances involved, travel along land and water routes takes a great deal of time. Most Americans go by air to Alaska, as they do to Hawaii, the island state. Located in the central part of the Pacific Ocean, the Hawaiian Islands are actually the tops of huge volcanic mountains rising from the ocean floor. There are 5 main islands: Kauai, Oahu, Molokai, Maui, and Hawaii, the largest island. All the islands were formed by volcanic action, and today the island of Hawaii still has 2 active volcanoes. The largest is snow-capped Mauna Loa. This is Kilauea, the more active of the 2. Eruptions occur frequently. When the lava cools and hardens, it gradually adds to the size of the volcanic island. Although most of the state of Hawaii lies south of the Tropic of Cancer, the tropical climate is mild and pleasant throughout the year, moderated both by the cool northeast winds and the warm ocean. Ties to the United States, 2,300 miles away, began in the late 1700s with the immigration of missionaries and other Americans. Economic ties began with sugarcane. It had been grown in the rich volcanic soil of the islands since earliest times. By the 1870s, large quantities of sugar were being shipped to refineries in the United States, and relationships strengthened, even though European countries tried to take over the islands. They had first been unified into a country by King Kamehameha, whose reign began in 1795. The last ruler of Hawaii was overthrown in 1893, Queen Liliuokalani. In 1900, her country became a United States territory. And in 1959, her home, Iolani Palace in Honolulu, became the seat of the state legislature as the Hawaiian Islands joined the Union as the 50th state. And the people celebrated. The new Capitol building was completed 10 years later, in 1969. Its open design symbolizes Hawaii's volcanic origins and island character. This is part of modern Hawaii. In modern Hawaii, sugarcane is still important. Labor-saving devices have reduced the workforce while increasing production. The cane is grown and harvested all year long. Pineapples, Hawaii's second largest crop, are grown on large plantations. Hawaii is the world's leading producer of this fruit. Almost all of the pineapples raised here are canned in the islands for shipment. The pineapple and sugarcane industries required many workers over the years. For generations, people came to Hawaii mainly from Asian lands to work in the fields, canneries, factories, and warehouses. They came from Japan and the Philippines and China. Their descendants make up a large part of Hawaii's present-day population. Both pineapples and sugar are exported to the mainland from ports such as Honolulu. Hawaii exports these agricultural products and imports most of the goods it requires. Near Honolulu Harbor is Pearl Harbor, an important part of United States history. Pearl Harbor is still a major naval base. Many civilians are employed at the Navy, Army, and Air Force bases on the islands. National defense is Hawaii's main source of income. But income from the tourist trade is second and rapidly growing. Waikiki Beach in Honolulu is probably the most famous of Hawaii's many beaches. Here, a favorite attraction for many tourists is the luau, a traditional Hawaiian feast. Others may prefer horseback riding along mountain trails. In the mountains, the beauty of the islands can be fully appreciated. Honolulu, center of the tourist industry, is also the largest commercial city in the islands. Life here is much like life in any medium-sized American city. And like other American cities, Honolulu is changing and growing rapidly. Agriculture is becoming less important. New construction is bringing roads, motels, and other commercial buildings. This is all part of the continuing development in Hawaii, the island state. Both Hawaii and Alaska, the two westernmost Pacific states, are major transportation links for shipping and air travel, connecting the East and Asia with the Western world. Both states export their main products while importing the goods they require. Alaska is a vast state with resources that have not yet been fully developed, while Hawaii, although much smaller, is being rapidly developed, mainly to service tourists. And population is growing in both states. In Alaska, the largest state, and in Hawaii, the island state.
Fascinating. All right, one last film. We've seen others in this series, and I love nothing better than an animated train to make its point.
We are traveling now in the land of the Ix, the ologies and the ometries. Ix, ologies, and ometries. They are friends of yours, but perhaps you know them better by their full names. Mathematics. Mathematics, 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 mathematics. Economics. Economics, economics. Electronics. Electronics, 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 electronics. Biology. Biology, 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 biology. Sociology. Sociology, 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 sociology. Geometry. Geometry, 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 geometry. There are many other vehicles in the land of Ix, ologies, and ometries. Vehicles such as genetics, zoology, and trigonometry. But by now you've guessed that they are all in the science and math areas. On this particular trip, we're interested in a particular kind of scenery. What is seen in math and science books? In other words, reading in the math science areas. A computer is a tireless servant of man, freeing human minds from the time-consuming calculations necessary in the fields of science and mathematics. But a computer is only a servant. People, or other machines people have built, feed the figures into a computer and indicate what operations it is to perform. And people read the results and decide what they mean. As you sit at your desk in your math or science class working problems, you are much, much better equipped to find solutions than all the computers in the world put together, provided you use your advantages. One of your outstanding advantages is that you can read. You can collect your own information, adding to it the wealth of information you have read or heard in the past, and use it to make decisions. It may seem strange to suggest to someone struggling with a page of sets and operations that he is working on reading problems. Or stranger still to suggest that every science experiment is first of all a reading lesson, but it's true. Just as a reading glass focuses the sun's rays, your reading skill brings all the facts to focus. And what happens next happens systematically. Systematically, the match head flames up, warming the air in the tube, making it expand so that it pushes the cork out of the tube. It happens the same way every time, time after time, systematically. Just as 2 plus 2 equals 4 every time, using any numerical system, for math and science are systematic bodies of knowledge. So if you sometimes seem to be going around in circles with math or science, perhaps your confusion arises from the way you read in these areas, rather than from the subjects themselves. Reading depends on your skill in identifying symbols. In the math area, you are well acquainted with the operation symbols which tell you to add, subtract, multiply, or divide. You know the meaning of the equality symbol. But do you know the meaning of this symbol? Or this one? Or this one? There are many symbols you may find reading in the math science areas which will be new to you. And you must treat such symbols differently from the way you would treat a new word in ordinary reading material. For example, here is a symbol you might find while reading in science. Let's assume you don't know the meaning of the symbol. In ordinary reading, you can often guess at the meaning of a new term by the way it's used, by its context. Here is how our symbol is used in one science book. You can guess that H2O is the symbol for some liquid, but which one? Gasoline, maple syrup, salad oil? The symbol H2O means water, and only water, so you would be wrong to guess anything else. The language of science and math is very exact, too exact for guessing. When you meet new symbols or words in your reading in science and math, don't guess. Look them up or ask your teacher. You cannot find what you're asked to find until you know exactly what the words and symbols mean. Once you know what a symbol means, you have a clue for what to do next in math, provided the symbol is stated. Here you add. Here you multiply. Here you subtract. Here you divide. But as you well know, in many math problems, the operation symbols aren't given. You must study the problem, decide what to do with the sets, decide which operation to use, and write an equation. Often the problem is half solved if you read it correctly, and the more times you read it, the more likely you are to read it right. Let's try it. Read this problem as I read it to you. A grocer bought 5 boxes of squash for his store. Each box contained 14 squash. He sold the squash for 15 cents each. How much money did he receive for all the squash? So what will your answer be in? Dollars and cents, boxes, or sets of squashes? That's right. You're looking for an answer that represents a certain sum of money. If you will always read the problem through until you are sure what is asked for, you won't come up with incomplete answers because you forgot one of the operations. To decide which operations to use when no symbols are given, review with your mind the different operations. Here is the operation multiplication. Will you use it? Yes. You want to find how many in all there are in 5 equal sets of 14. And also how many dollars and cents the grocer will receive selling all the squash at an equal price, 15 cents. By reviewing operations, you know which operational symbols to use to set up your equation. The symbol for multiplication. The rest is arithmetic. And if you work the arithmetic as carefully as you have just read your problem, you will have the right answer. Your understanding of many of the things you read in science may depend on how well you can read a diagram. Diagrams are entirely different from signs and symbols. Signs and symbols have exact meanings. You cannot guess or use your imagination with them. But diagrams such as this demand that you use your imagination. And sometimes it takes plenty. This diagram represents the molecular structure of paraffin, the stuff from which candles are made. A molecule is too small to see, yet each molecule in this candle has 26 atoms of carbon and 54 atoms of hydrogen. The diagram shows you how the atoms are arranged, if you will use your imagination to visualize a tiny bit of matter with so many different parts. Another diagram in a science book may indicate the meeting of a cold air mass with a warm air mass. Is cold air really blue? Do you suppose cold air always moves from left to right? Of course not. But here, as with all diagrams, you must use your imagination to see what actually cannot be seen. Using your imagination to read the diagrams will clarify the textbook description. The experiments you find in your science books can help you understand the material in the text, but only if you read the experiments in a special way. Read the experiment as if you were a scientist trying to discover a truth never known before. Such people do not experiment just to see what will happen. They think they know what will happen, and they experiment to prove it. Dr. Jonas Salk thought he could kill viruses which cause polio and use these killed viruses to make a vaccine which would immunize people against polio. That's what he set out to prove. And what a scientist sets out to prove is called the hypothesis. Science books usually present several pages of text material before the experiments. The facts in the text can help you develop a hypothesis as you read the experiment the first time. Develop some statement which you think the experiment may prove. Many times a text will state the hypothesis. For example,
notice that the bone is shaped like a tube. So are most of the long bones in a chicken and in all other bony animals, including you. Do you suppose that this shape has a special advantage? One advantage is that the space in the tube can be used for marrow, but many bones have no marrow, and yet they are tube-shaped. Is there some other advantage in this shape? Let's find out.
Let's find out. Let's find out if there is some other advantage of a hollow tube compared to structure made of the same amount of material. There probably is such an advantage. That's our hypothesis. Now we read the experiment through again to see what materials we need to perform it and what we are to do with them. With the materials assembled, 2 pieces of paper and tape to fasten them, we read the experiment step by step as we go along, following the directions exactly. That's all we're supposed to do with this piece of paper in this step. Now we read and follow the next step in the directions. There's that step completed. And now to compare the solid shaft and the hollow shaft made from the same amount of material. Does the experiment prove our hypothesis? Is there an advantage to the hollow shape? What is the advantage? So that you can review the steps necessary in reading an experiment, we're going to give you 5 seconds to supply the number of the correct answers in a short quiz on reading experiments. Why do you read the text material first? To get the facts used in the experiment. If no hypothesis is stated, why do you read the experiment all the way through the first time? to develop a hypothesis, to decide what the experiment may prove. Why do you read the experiment again? To carry out the directions in order. If you always take these 3 steps when you read an experiment, you'll have the satisfaction of discovering many of the truths in our scientific world at first hand. And that includes those studying the science of home economics. A recipe, like an experiment, has a hypothesis you can eat if you read the recipe through and get the hypothesis in mind. And then reread as you go along to get the steps in the correct order. In the future, your families will test your ability to read home economics experiments 3 times a day. So learn now to do it well.
It says 2/3 of a cup of milk. Making twice as much, what would it be? 2/3 times 2, 4/3, or 1 1/3 cups of milk. Pour the milk.
It may seem a long way from the everyday arithmetic of figuring amounts of ingredients when you want to double a recipe for muffins, to the highly complex transactions handled by a computer, which may be charting man's voyages into space. Yet the youngsters at home and the adults at the Space Flight Operations Center are all involved with reading the math science areas, all contributing to research in the X and the ologies. Your success with reading in the math science areas will give you satisfaction right now. But even more important, it will prepare you for greater satisfactions to come as you take your place in a scientific world.
I kind of like that recipe. Yeah. And I think I got one more in this reading series. That might feature another animated train. I don't know. So tomorrow, I'm not sure if I'm going to be able to do this show live or not, because tentatively I thought that I had an appointment for getting our cat a steroid shot. But I'm not seeing the vet hospital said, like, yeah, you need to book an appointment with us. So I'm not sure exactly what happened, but I'm going to call and check. So I'll see you tomorrow. Either it'll be pre-recorded or it'll be live. There will be some Spanish lessons. There will be some French lessons, etc. All right. Thanks, everybody, for tuning in. I appreciate it. And I will see you tomorrow. And thank you, Rich, and thank you, Kevin, for supporting us with the super thanks button. You can also subscribe. You can go to patreon.com/avgeeks, and that's kind of like a subscription tip jar. Or you can just buy us some coffee at ko-fi.com/avgeeks. All wonderful ways to support us. Even just watching helps. Thanks so much. We will see you tomorrow. Take care.